lesson 4, which is on page 23 of your photocopied booklet. If you printed it and yours doesn't say page 23, then you need to label it, please. So today we're looking at equation of a line and how we can come up with that equation. So we're going to do a little investigation first. This first question asks us to make a table of values and then graph the line. So here is the equation that they have given us, right there. And they have given us an x value of -2. So to get the y value, I'm just going to go plug in for -2. And I'm going to figure out what this is. So 4 plus 3, which is 7. So it looks like this over here is going to be -2, 7, which doesn't quite fit on the page, but it's going to be up here. So that's the first point. And then if I do the second point, which is -2 and then -1, then we have 2 plus 3, which is 5. So apparently there's a point at -1, 5, which will be right here. And I can keep going. Y is equal to -2 times 0 plus 3. So that just ends up being 3. So 0, 3. And you can already see what the pattern is of the line. So y is equal to -2 times 1 plus 3, which is going to be -2 plus 3, which is 1. So this is 1. And you can see that each time, because we're stepping down by 1 in the x's, each time it's actually stepping down by 2. So if you're to do that, which by the way, I misplotted this one, it should be 1 down, because 1, 1 is here. If you step down by 2 another time, you can already see that this is going to be -1 down here. So 2, -1. And there is our line. So I'm going to go ahead and sketch that. And I'm going to extend this to the edge of the graph. And I'm going to put an arrow at the end of each of these. So I'm just going to erase this stuff for now, because I want to answer the next question, which is, state the coefficient on x and the constant of the equation. So the coefficient of x, you can see from the equation is actually -2. And then the constant of the equation is 3. And then the last part of the question asks us to state the slope and the y-intercept. So to calculate the slope, we can take a look at our graph. And we can see that there's like a rise over a run. So I can actually use, for example, these 2 points because they are exact. And I can look for a rise and a run. So the rise is 2 and the rise is 1. And this is actually a negative slope because it falls to the right. So my slope is actually -2 if I calculate it from there. And then if I look at my y-intercept, well, where is that? It happens to be right here. The y-intercept is 3. So is it a coincidence that the coefficient of x is -2 and the slope is -2, the constant is 3, the y-intercept is 3? Probably not a coincidence. So I'm supposed to do the same thing for the next equation. I'm just going to skip this one for the time being, and I'm going to go to the next one. And we'll come back to that one in a second. So this one asks us to do the same thing. Can we create a table of values? So y is equal to 4x. So 4 times -2 is supposed to give me y. So -8. So -8 is here. See how I've just plugged in those x values to try and get the y value. Y is 4 times -1, which is -4. So this is going to be -4 in here. Y is equal to 4 times 0, which is 0. So that'll go here. Y is equal to 4 times 1, which is 4. And y is equal to 4 times 2, which is 8. So I can go ahead and plot these now. There's a point at -2, -8, which is going to be down here. Unfortunately, there's not enough room on that graph. Okay. Then there's going to be a point at -1, -4, which is here. Not there. -1, -4, which is here. There's going to be a point at 0, 0, a point at 1, 4, and a point at 2, 8, which is really too high up. So what I'm going to do is I'm just going to draw from here. Here is my graph. That last point is a little bit off because I ran out of grid. So I'm just going to draw like this. Okay. So then I just put arrows on the ends. And then I go back to what the question was asking. So I'm just going to delete my scratch work here. And it asked us to determine the coefficient of x and the constant. Okay, so according to the equation over here, the coefficient of x is 4. And the constant, wait a second, there is no constant because it's missing from here. There's nothing here. So I can say that the constant is 0. And what else did it ask us to do? It asked us to look at the graph and try and read the slope, try and read the y-intercept. So I'm going to go ahead and try and do that. So let's read the slope. This is a legitimate point up here, and this is a legitimate point. So I'm going to read a rise over a run. Looks like a rise of 4 and a run of 1. So the slope is going to be 4 over 1, and it is a positive slope because it's rising to the right. So the slope is 4. And the y-intercept, I just got to read it off the graph here. It looks like the y-intercept is 0. So is it a coincidence that the coefficient is 4 and the slope is 4, the constant is 0, and the y-intercept is 0? Well, no, we know that this is how equations actually work. So if you were to look at this equation right here, you would be able to tell right away that because the coefficient of x is 1/2, you know that the slope is going to be 1/2. And because you know that the constant in this case is -2, you already know that the y-intercept is going to be -2. And if you know these things, you can plot this a lot faster. So I'm going to start with the y-intercept at -2, and I'm going to plot a slope of 1/2. That's a rise by 1 and a run by 2. Rise by 1, run by 2. Rise by -1, run by -2, and so on. And so if you know all that information just from the equation, then you can draw your line much more quickly. You can put arrows at the end of that one as well. So this is on page 24. And it tells us about this linear equation. So a linear equation is always going to take this form, well, almost always, going to take this form. And there's two significant pieces here. There's the m, which you guys know is the slope. And there's the b, which is going to be your y-intercept. And if you know those two things, it's going to be very easy to plot your line. So the coefficient of x is the slope, the constant term is the y-intercept. So if I look at something like this, example number 1, very quickly I can tell that the slope is going to be 2 and the y-intercept is -7. Over here, I can quickly tell that the slope is 3/4, 3 over 4, and the y-intercept is -1. Over here, it gets very complicated because what on earth has happened here? Why is it, where's my x? Like, what is this? So what's happened is they've actually got 0 as a slope. So what's happened is the 0 has caused the x term to just drop out. So if the coefficient of x is 0, the entire x term will disappear, which is exactly what happened here. So the slope of this one is actually 0, and the y-intercept is -5. The slope of this one is 4, and the constant seems to be missing. So it's actually 0. The y-intercept is 0. And in the last case, the slope is -4/3, and the y-intercept is 4. So I will not plot all these lines. I will just plot a few of them. So I'll plot the first 3. The first one has a y-intercept of -7. So that's usually the easiest way to start. 1, 2, 3, 4, 5, 6, 7. Here's my first line. And then I'm going to rise by a slope of 2. So that's 2 over 1. So I'm going to rise by 2, run by 1, rise by 2, run by 1, rise by 2, run by 1, and so on and so forth. So if you do this, you will be able to draw your line quite quickly. So the starting point that I'm always using is that y-intercept. It's going to be the fastest way for me to start. So I'm just going to label this. This is actually line 1. I will also draw line 2. So this one has a y-intercept of -1. But the slope is 3 over 4. So I'm going to rise by 3. 1, 2, 3. Run by 4. Rise by 3. Run by 4. And because I need to run the other way, I'm going to rise by -3 and run by -4. So I can get some points on this side. And that's how I'm going to draw my line over here. So this here's line 2. What's really interesting is line 3. So I'm going to label that line 2. Line 3 has a y-intercept of -5, so we can go ahead and plot that, 1, 2, 3, 4, 5. But it actually has a slope of 0. So what does the slope of 0 actually mean? So there was some argument about whether 0 meant vertical or horizontal. But check your notes. A slope of 0 is a horizontal line. So we know that this line is just going to be horizontal, like so. Okay? So what if they give us the picture? I'm not going to draw the rest. I'm sure you could figure it out. What if they give us the picture and then they want us to come up with the equation? So let's go to line A over here. And we are asked to calculate the slope, which is like, sure, okay, but to calculate the slope, you need to find 2 points that lie very conveniently. So these ones lie exactly on the grid. And I see a rise of 4 and a run of 2. But if I'm doing a rise of 4 and a run of 2, that simplifies to 2. And then I've got to ask myself, is it positive or negative? Well, it falls to the right, so this is actually a negative slope. So that's how you would calculate the slope of A. And then they also want the y-intercept, which is 1. So then the equation of this line, which recall is y is equal to mx plus b, that's the format. So I'm going to get y is equal to -2x plus 1. Let's do another example. So I'm looking for the slope of b. So if I just erase this dot here, because I want to see if that's legit. I believe that point is not legitimate right here, but this one is, and this one is. So I'm looking at a rise of 1, 2, 3, 4, 5, 6, and a run of 1. So 6 over 1 is 6. And is this positive or negative? Well, it's rising to the right, so I'm going to call this a positive slope. The y-intercept is right here at 0. So the equation of my line is going to be 6x plus 0. But you don't have to write the 0, and as a matter of fact, you really shouldn't. So it's just going to be y is equal to 6x. Graph C. Let's find the slope. Let's pick 2 convenient points to measure. So here, that point lies exactly on the grid, and that point does. So I'm going to do a rise over a run. So it looks like my rise is 3, and my run is 1, 2, 3, 4, 5, 6. So 3 over 6 is my rise over run. So then that ends up being a slope of 1/2. If you put 3 over 6, it's wrong. And then I got to ask myself, is it positive or is it negative slope? And because it rises to the right, it's a positive slope. Let's look at the y-intercept. Looks like it's 3. So y is equal to 1/2 x plus 3. And then we'll do one more. We'll just do D, just so we can see what's going on. And let's pick 2 convenient points. That one's pretty convenient, and this one. So we got a rise of 2 and a run of 1, 2, 3, 4, 5, 6, 7, 8, looks like. Yeah, so 2 over 8 is 1/4. But is it positive or negative? Well, it falls to the right, so I'm going to call that a negative slope. And then my y-intercept is -5. So the equation is -1/4 x minus 5. I'm not going to do the last one because I think you guys get the idea. So once you have a slope and a y-intercept, you can write the equation of the line. Except that there are some special cases. So we've already talked about a horizontal line. A horizontal line has a slope of 0. So if you put a coefficient of 0 on the x, then what happens is that the x term will disappear. And if the x term disappears, then you're just going to have an equation that looks like y equals a number. So the equation y equals k represents a horizontal line through a y-intercept of 0, k. So for example, if I had a y-intercept of, say, 3, and I drew a line through there, like that, then the equation of that line would just be y equals 3. A vertical line is a little bit different. So a vertical line has an undefined slope. And the best way I can explain this is to draw a picture here. So let's suppose that I want to draw a vertical line right here at 3. So here's my vertical line. And I want to come up with all the coordinates of everything on this line. So if I look at the coordinates of this, that point is 3, 0. This point up here is maybe 5, 0. This one down here I don't know, it's maybe -6, 0. So you see that all of the y values are 0 and all of the x values are different numbers. Sorry, that's not true. That's not 5, 0. This will be 3, 5. That's not true at all. Sorry, guys. The coordinates of this point are going to be 3, -6. Right. So they all have the same x value. It's just that they're at different heights, so they're going to have different y values. Okay? So no matter what value you pick along this line, it is going to have an x value of 3. So the equation of this line is going to be x is equal to 3, no matter what y is. And that's really confusing because it's difficult for students to process what this undefined slope actually means. So the equation x equals k represents a vertical line through a, 0. So the special cases are that if you have a horizontal line, it's going to say y equals something. And if you say a vertical line, it's going to just be x equals something. So we have these special equations that look very simple, and they are for vertical and horizontal lines. So here's an example. It says, can we determine the equation of these lines? A horizontal line that runs through this point. And I'll tell you right now, you are going to see examples like this on your quiz. And the best way to do this is to draw a sketch. So can I run a horizontal line that runs to the point 5, -3? So 5, 3, 4, 5, -3. 1, 2, 3. So this is the point 5, -3. And I'm trying to run a horizontal line through this point. So like this. So I can start to use my imagination and say, okay, well, let's label a few more points on this line. This is going to be 0, -3. This one over here, oh, I don't know. It's probably like -2, -3. So what do all these points have in common? They all have different x values, but they all have the same y value. So because of that, you can remember then that the equation of a horizontal line is going to be y is equal to -3. How come? Because all the y values are -3. That's why. Okay. Contrast that with the second example, which says, can we run a vertical line through -2, 9? So where's -2, 9? -2 is here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here's -2, -9. And if I run a horizontal or a vertical line through that point, we can start to investigate what the points sort of look like. So we might have a point here, which is like -2, 2, maybe a point here, -2, 4. So you can see that all of the points on this vertical line have the same x value, they just have different y values. So what is the equation of this then? Well, x is always -2, so the equation is x equals -2 for that particular line. So the reason why this is confusing to students is they're like, okay, so 5, 3, y equals -3. Does the 5 not matter? And the answer is, well, no, the 5 doesn't matter. Because look, like it could be 5 here and then 0 and then -2. What matters is that if you're a horizontal line, all the y values are the same. And in a vertical line, all the x values are the same. That's what's happening here. Example number 4. Given this equation, algebraically determine the x and y intercepts. So I want to point out something really important about this equation, which is I told you that equations are supposed to look like this, y equals mx plus b. This one does not look like that unless you rearrange it. Like if you want to minus the 4x from both sides, then it will look like the format that you're supposed to know. If it's not in the correct format, you cannot tell anything about the equation. Some students would say, oh, I can tell the slope. The slope is 4. And you'd actually be wrong because the slope is -4. So the important thing is you need to rearrange it so it actually looks like y equals mx plus b. Otherwise, you can't tell anything about it. So now that it is in this format, I know that this is the y-intercept. Okay? But how do I determine the x-intercept? Well, the x-intercept, remember, is always going to be an x value comma, 0. So if you want to determine the x-intercept, you can use this equation and you can put in 0 for y and solve for x. So 0 is equal to negative 4x plus 2. I can minus 2 from both sides. Negative 2 is equal to negative 4x. 5 by negative 4. And I'm going to get x is equal to 1/2. So this is my x-intercept. So unfortunately, as nice as y equals mx plus b is, it tells you the slope, it tells you the y-intercept, but it will not tell you the x-intercept. So to do that, you actually have to plug in 0 for y and solve for x. What about part B, where it asks, do these points actually lie on the line? So how can we check that? Well, have you seen before that you can actually plug these into the formula, x comma y, and just check and see if the left side equals the right side? You can use the original formula. That is totally fine, but I recommend using the y equals mx plus b. So let's use this format. Y is equal to, okay, and I'll put in my x value, plus 2. So notice how this is the exact equation in black here, except I've put in negative 6 for y, and I've put in 2 for x. And let's see if the left side equals the right side. Looks like it's good. So if the left side equals the right side, then you can say that yes, this point does lie on the line. Let's see what happens in this case right here. So here's x and here's y. So I'll use the same equation, but I'll just put 4 in for y and negative 1 for x. And let's see what happens. 4 is equal to 4 plus 2. 4 is equal to 6. So because the left side does not equal the right side, we are saying that this point actually does not lie on the line. So you just have to plug it into the equation and see if the left side equals the right side. In example number 5, a line is defined by this equation. State the slope and the y-intercept of the line. Now, let me tell you what a rookie would do. They would look at this and say, oh, the coefficient of x is 3, so 3 is the slope. And then they would say, oh, 8 is the constant, so this is the y-intercept. But that would be very, very wrong. What is the problem with that? How come we can't just read directly off the equation? The problem here is that it is not in y equals mx plus b format. Okay, it has to look like this, otherwise we can't tell anything about it. So let's go ahead and rearrange that. So here's where we started. Let's move the 3x to try and isolate for y. If we do that, we have negative 2y is equal to negative 3x plus 8. But then you have to divide everything by 2, negative 2. And what do I mean by everything? I mean like every term. Okay, and then if you do that, then y will be successfully isolated. So then these cancel out. These negatives cancel out, so you're going to have 3 over 2x minus 4. So the actual answer for the slope is this one here. The slope is 3/2. And negative 4 is the y-intercept. So if we had gone with our original red answers, you can see that we'd be very, very wrong because we did not rearrange it first into y equals mx plus b format. Example number 6. We have an equation of a line, y equals mx minus 6, but the slope is missing. And they want us to determine the slope. But they've given us an extra little clue. They've given us that it runs through this point, x comma y. If we know that it runs through this point, then we can plug in for x and y. And we know that it's supposed to work, okay? So x is 2, and y is 4. So we can actually plug in for these and find m. They've just given us a bunch of clues. So we'll go ahead and write that out. 4 is equal to 2m, or m times 2, minus 6. And then we can solve for m. So m is equal to 5. And we have successfully solved for the slope. Okay. In the second example, they've given us a partial equation of a line. They've given us a slope, but they're missing the y-intercept. But again, they've given us this extra clue that this point lies on the line. So we can put in -4 for x, and 7 for y. And once we have those, then we can solve for b. So 7 is equal to -3 halves times -4 plus b. How do I deal with this? Just be really careful, guys. This is a fraction times a fraction. So this is actually 12 over 2, which is 6. So you can see that b is going to be 1. Okay, so if you are missing a value like b or m, but you have a point, you can plug in for x and y. You can solve for that value. It's just hard right here. This is where students would make a mistake. Example number 8. Determine the equation of a line that runs through these 2 points. This one's really, really hard because usually to determine the equation of a line, we need to know what m is and we need to know what b is. And we don't have either of those things. All we have are these 2 points. But do we have a method if we have 2 points? Can we determine m? So just a reminder from lesson 3, you have a slope formula. So we have a slope formula that says y2 minus y1 over x2 minus x1, and that'll allow you to find the slope between any 2 points. So you just got to label them x1, y1, x2, y2. So we can calculate 18 minus -3 over -4 minus 2, and I'm getting 21 over -6. And because they both divide by 3, I can do like a 7 over 2 negative. Okay, so far here's what I have. Y is equal to -7 halves x plus b, which is pretty darn good for an equation because the only thing that I have missing is b, because I just found the slope. Yay. But they need us to determine the entire equation, which means that I have to find out what b actually is. So what I would do in this case is I would do exactly what I did here. I would say, well, I almost have the whole equation. I just need a clue, a point. And actually, we have 2 points. So you can use whichever one you want, and you can plug in, let's say, 2. Right? You can plug in 2 for this one. You can plug in -3, and then you can actually solve for b. So let's go ahead and do that. -3 is equal to 7 halves times 2 plus b. So how do I deal with these fractions? Well, this is a fraction times a fraction. So this is going to be -14 over 2, which, spoilers, is going to be -7. So -3 is equal to -7 plus b. I can add 7 to both sides, and I can see b is going to come out to be 4. So my final answer, once I have m and I have b, is I can write the equation of the line. -7 halves x plus 4. How did I get all these pieces? Let's reflect. So I got the slope by doing all this stuff in black by using the slope formula from the last lesson. How did I find b? Well, I wrote my partial equation, I plugged in a point, and then I actually solved for b. So this is a multi-step question. It is quite difficult, and you'd have to be able to see that that is what you have to do in order to get there.